Okay, let's look at question number 23. Now, this used to be a very, very popular question, very, very simple, but let's try doing it. Okay, so you are given a track along with the aircraft is flying, and you have three different points. It could be aerodrome's waypoint, whatever it is, X, Y, and Z, and your given distance between X and Y is 30 nautical miles and Y and Z is 20 nautical miles. Actual time of arrival, that's ATA, the actual time you reach a particular point, at X is 1420. All right, so let's put this diagram again here. And the actual time of arrival, that is ATA at X, is 1420, right? That's the time of arrival at X. Let's kind of draw this diagram very quickly. So I'm not taking much time for this particular diagram here. I know you know it. This is just for students who kind of surprised to see this question. This used to be a very popular question, as I told you before. All right. So this is X here, Y, and Z, and the distance is 30 nautical miles XY, and YZ is 20 nautical miles. The actual time of arrival at X is 1420, and the estimated time of arrival, which is the ETA, at Y is 1447. So while you are at X, you have the actual time with you, and you have the previous ground speed, the ground speed at which you flew the previous leg. And using the ground speed and the distance of 30 nautical miles, we kind of estimated the estimated time of arrival at Y, and that's exactly what we did in the previous question right here, where we kind of found the estimates using the ground speed from the previous leg, right? So the ETA is 1447, but what you eventually find out is the actual time of arrival. That's right here, actual time of arrival in the question at Y is 1450, which means even though your estimates were 1447, you got delayed by 3 minutes, and the actual time of arrival at point Y is 1450. So you can very well see that there is a delay of 3 minutes. And if you don't do anything about it, the delay is going to just get carried forward. So what are we asking the question is to find the new ETA at Z. So you have to find out the new ETA at Z. It's called new ETA because for obvious reasons the ETA would have changed, because you have a delay in the previous leg which would get carried forward if you don't do anything about it. So in this particular scenario, we assume that we're not really correcting it, we're just going forward with what we have. And for that reason, let's find out the ground speed which we actually experienced during the leg XY. So taking the leg XY, right? So we can find out the ground speed, but the basic speed distance time equation, ground speed is equal to distance traveled divided by time, and distance traveled was 30 nautical miles divided by time taken is the actual time of arrival at X is 1420, and the actual time of arrival at Y is 1450, and that is 30 minutes. And remember, it's again in minutes, and be very, very careful to convert that to hours, and that is equal to 60 knots. And it's pretty clear that if you're traveling 30 nautical miles in 30 minutes, your ground speed is going to be 60 nautical miles. Perfect. That is 60. Now we assume that this ground speed of 60 knots is maintained in the next leg as well. We will be experiencing the same amount of winds, same power setting, and therefore the same ground speed. And we kind of estimate the new ETA at the next waypoint, which is asked in the question. So leg YZ, the distance is 20 nautical miles. Let's find out the time that it would take. Its distance divided by the ground speed from the previous leg, which is XY. So distance is again 20 nautical miles divided by the ground speed in the previous leg is 60 knots. Therefore the units are kind of in line. 20 minutes. Right, so the actual time of arrival at Y is 1450. We don't have any halt or any kind of holding, nothing over there. Keep traveling. Therefore, the actual time of arrival at Y being 1450, and the estimated time interval, that's what we got as 20 minutes, right? So the estimated time of arrival at the next destination with Z will be 15:10. Right, so you can see here you're asked to find out the new ETA at Z, and that is 15:10. You can do this question a different way. You can again assume the ground speed to be 60 knots throughout the journey. You can find out the ETA at Z, and then you can kind of add the delay of 3 minutes, and that is also going to amount to the same answer. But in either ways, it's the same. This is why I did this question this particular way, because it kind of reciprocates with the very previous question which we did. So it's kind of in line with that, and then this is more practical. So in the actual aircraft, when you kind of find that there's a difference between your ETA and the ATA, then you kind of find the previous ground speed, and you kind of use the ground speed to estimate the time that you would reach the next waypoint. Right, that is how it is actually done, and hence I've done this question in the same format. All right, pretty simple question, right? As I said, it's kind of a very public question, and most of you might even know it. And this question is particularly for those students who are kind of fumbling with the basics. I hope it really helped, and let's move on to the very next question without any further delay.